All right, let's just jump right in today with an idea that is so far out there it sounds like pure science fiction. We're talking about building our most powerful, most advanced computers on the moon. Yeah, you heard that right. This is a wild one, so let's get into it.
This quote pretty much says it all. The idea is that the coldest, darkest places on the moon are the perfect home for quantum computers. Now, when you first hear that, you have to ask yourself, right? Is this just some crazy headline-grabbing fantasy? Or is this actually brilliant? So here's how we're going to break this down. First, we'll ask why anyone would even think of this. Then, we'll see why the moon might just be the perfect answer to our biggest problem. We'll look at the actual blueprint, explore the huge, big-picture dream, and then, we'll bring it all back down to Earth with a big dose of reality.
Okay, so first up, is this really just a sci-fi moonshot? Well, before you can even wrap your head around moving computers off-planet, you've got to understand the massive headache they're causing us right here on Earth. The big bad wolf of quantum computing has a name: decoherence. You see, a quantum bit, a qubit, is just ridiculously fragile. The slightest little thing, a tiny change in temperature, a little vibration, a stray cosmic ray, and poof, it loses its quantum magic and the whole computation fails. That analogy of trying to hear a whisper in a hurricane is honestly not an exaggeration.
So, what do we do about it here on Earth? Well, we basically declare war on the environment. We build these absolutely enormous, complex labs with giant refrigerators to get near absolute zero, perfect vacuum chambers, and tons of shielding. It costs a fortune and uses an unbelievable amount of energy, all just to create this tiny, quiet space for the qubits to do their thing. And that brings us to the big idea. Earth's problem, meet the moon's solution. What if we just stopped fighting nature? What if we went somewhere that nature has already built the perfect laboratory, and it's just sitting there, waiting for us, for free?
Okay, now this is where it gets really compelling. Let's just do a side-by-side comparison. Temperature? The moon's craters are naturally at a level we spend millions and megawatts to achieve. Vibrations? Earth is constantly shaking. The moon is basically dead silent. All that electromagnetic noise from our phones and radios? Gone. And the vacuum? It's a vacuum so pure it makes our absolute best labs look like a crowded room. The moon just wins, hands down, on every single metric.
And let's just pause on that temperature. Minus 400 degrees Fahrenheit? Let me say that again. Minus 400. That is literally colder than the surface of Pluto. It's a natural cosmic freezer just sitting there, a gift that would be almost impossible to build and sustain on Earth without an insane power plant running 24/7.
And if that wasn't enough, check this out. The moon is just sitting on an estimated 1 million tons of something called helium-3. Now, helium-3 is basically super fuel for the deep freeze cooling that quantum computers need. On Earth, it is incredibly, ridiculously rare. The moon has a treasure trove of it, enough to fuel this whole quantum revolution and maybe even kickstart a fusion energy revolution on the side. And the list of advantages just keeps going. You've got natural radiation shields built right in, thanks to the deep craters and old lava tubes. The low gravity? It could open up a whole new world of quantum experiments we can't even dream of attempting here. And the silence? I mean, perfect absolute silence. No wind, no weather, no noise. It is quite literally a quantum physicist's paradise. All right, so the why is pretty solid, right? The physics makes a ton of sense, but the big question is how? How in the world would we actually build something like this? So let's get into the engineering blueprint. Well, this isn't some let's do it tomorrow kind of plan. It's a long-term, step-by-step vision. Phase 1, you send in the robots to scout out the best real estate. Phase 2, you start building, get the first processor online, and set up a small plant to start refining that helium-3. And then, Phase 3, you go big. You scale up to computers with thousands of qubits and start weaving it all together into a space-based quantum internet. Now, you're probably thinking, okay, but how do you power something that's sitting in permanent darkness, and how do you talk to it from Earth? Well, the solutions are actually pretty clever. For power, you just put solar farms on the rims of the craters, where the sun always shines, and you beam the energy down. Simple. And for communication, there's a 2.5-second round-trip delay, but for the kinds of massive problems these computers would be solving, that's totally manageable. So let's zoom out now, because we're not just talking about one computer anymore. This is the big so what moment. This is about laying the groundwork for, well, maybe a whole new kind of civilization. See, a quantum hub on the moon wouldn't just sit there in isolation.
It would become the heart of a brand new space-based quantum internet. It could link Earth, the Moon, and maybe one day Mars. And the best part? It would be secured by the laws of physics themselves. With quantum encryption, if anyone tries to eavesdrop, the message literally breaks, and you know instantly. It's not just hard to crack, it's impossible to crack.
And this is where it all fits into that grander vision of making humanity a multi-planetary species. You'd have this self-sustaining research outpost powered by the sun and fueled by the moon itself. The discoveries that could come out of that, in AI, fusion, medicine, you name it, would be staggering. And, it's also about not keeping all our technological eggs in one basket. It's a backup for humanity, just in case.
But, okay, deep breath. As incredible as that all sounds, we have to ground ourselves. It's time for the reality check, because the hurdles between here and there are, well, astronomical. First off, the price tag. We're looking at an estimated $74 billion. That's a lot of rocket launches. Then there's maintenance. Can you even imagine trying to repair a super delicate quantum circuit in that abrasive, static-charged moon dust? Nightmare fuel. And that 2.5-second lag, while fine for some things, is a deal-breaker for others. And finally, you get into the really messy human stuff, geopolitics. Who owns the moon's resources? Who gets that helium-3? And how do you make sure this doesn't become the next great weapon?
So it all comes down to this question, doesn't it? The 20th century was defined by silicon, powered by the sun. The 21st century seems to be all about the qubit, our most advanced, hottest new technology. And the beautiful irony is that its ultimate home might be in the coldest, darkest shadows our solar system has to offer. So what do you think? Is this the future? Or is it a moonshot that's just a little too far?